Okay, it's fine. Let's start. So in the last class, we have seen the theoretical meaning of train test split. Okay. And we understood many things regarding that. Okay, fine. So mainly when you use SQL model selection and import train test split, and to this train test split, the name itself is saying I'm audible, right? And my screen is also visible, right?
Yes, Santosh.
Okay. So when you the name itself is saying that train test split, that means it will divide the data into train and test. Okay, to this you need to divide the data. Sorry, you need to pass the data. So over here, this x is actual overall x and overall y. From where did we get? Yeah, the given data, this is the overall data, including input and output. So that we have divided into x and y. This x and y, we need to pass it over here. Okay, you have passed it. And it will divide it into train data and test data. And what is the percentage that you need to mention it over here. Okay, so we mention only test size. There is no option to mention train size, because if you mention 0.1, automatically the remaining 0.9% will be allocated to training data. Okay, that's fine. But the important point here is how, in what order it is going to divide. So obviously we understood that it is when you are dividing, see, you are having x and you are having y. What is this? Input and output. Okay, or features and label. And in the overall, okay, 1 second. Show the actual data. Huh. So which we have shown yesterday, but let me show you again. Fine. So you are having these two input x and this is placement as y. Okay, this is the from given data, and this is the overall data, for example. And we are saying divide it into train data and test data. Okay, randomly it divides. Okay, for example, let's say till here it becomes train. This is becoming test. Fine. So now you are having four parts. What? X train. Okay, and you are having this is y train. Sorry. Similarly, X test and Y test. Got it? So, but the order which the train test split will give us is this order. X train, X test, Y train, Y test. That means what? It is giving you first X train, this data, X test. X first X values it is giving, and next Y value, Y train and Y test. Okay? The order is important. Fine. So now you got all the four required data. Okay. Now, if you want to take a look, you can take a look. So if you see here, when I print X train, give me a second. Yeah. So as you can see, this is the X train. Okay. And the overall, if you remember, the overall data is 100 and test size 0.1, that means 10%, that means 10 rows. Remaining 90 will be train. So that's why if you see 90 rows in the X train. Getting? And as you can see, it's not like top 90, it's just randomly 90 rows it took. Cool. Next, I can also show you, let's say, X test. Okay. Whatever the indexes that are missing over here will be here. And here you can see just 10, because you have mentioned 0.1, 10%. Okay. Similarly, Y train. Okay. And also Y test. Fine. So over here, Y train will have 90. So as you can see, length is 90. Y test is having only 10. Okay. But if you observe the same rows, X test and Y test will have the same rows, 23, 43, 42, see 23, 43, 42, that way. Okay. Getting guys? And X train will have 57, 80, 41. Same will be repeated here, 57, 80, 41. Okay, this is how you will get four different types of data sets. Are we good till this point?
Yes, Santosh.
Okay. Now that is done. After that, now what we got? Data, as I said, you need, or just a second, let me know. Yeah. So from this, we have reached till this point. The data we had, we divided into train data and test data. Done. So this you already know. Train data we use for training purpose, test is this purpose. Okay. Now what is happening over here? Yeah, we are doing one more step here. That's called scaling, guys. Okay. So what is scaling? How many different types of scalings are there? So that I'll be showing you when we discuss scaling concepts. Okay, but the main point of the scaling over here is, let me tell you. See here, if you observe, see now we got the data. What data we are going to pass to the model, guys? We are going to pass X train and Y train. Okay, we are going to pass X train and Y train. We are passing training data, input, output. Clear? So now if you see Y train is just what? Output, what is whether it is 0 or 1. Okay, but the main thing is X train input. What input we are passing? X train. So when you look at the X train, see this is the X train. It is having two columns. One is CGPA and IQ. But the problem here is if you see CGPA, it is having a range of just, it looks like it is just below less than 10, because these are grades, because it will be less than 10. Okay, and if you see IQ, the values are always greater than 100. Getting? Over here CGPA, every value is less than 10, but in IQ most of the values are greater than 100. Okay, now the problem with this is, if you pass this data, this X train as it is to any model, you will get results. You see, even if you pass completely junk data or missing values data, you will get results. Okay, but it is useless because it's not capturing the actual meaning. So what happens over here, if you, the accuracy will be very, very poor if you do that. Okay, so in this case, if you pass it this way, what happens is, to the ML model, because model understands only numbers, fine. When you are passing this as such, it will unnecessarily feel that IQ is more important than CGPA because it is having higher bigger numbers. Okay, so it will create a false interpretation to the model. Okay, that IQ, which is having big numbers, is more important, okay, to the CGPA, because from model perspective, everything is numbers. Agree? It doesn't understand any characters. So when you say numbers, obviously, when you have 1, 2, 3, 4, 5, so in max, 5 is greater than 1. The bigger the number, the higher its value, right? So that's why here when you give IQ, which is having big numbers, it will think that IQ is more important than CGPA. Okay, but that is wrong. Because who is saying that? Nobody is saying. We don't know. CGPA might be more important. Just because the values are small, that doesn't mean it is not important, right? So to avoid this, okay, but we don't know. Really, IQ might be important or CGPA might be important in predicting the output value, in predicting the output placement. We don't know what is the contribution of each of these. Okay, that is a job of the model to find out. Okay, so our job is to give equal importance to both of them. We should not be biased. We should not have any partiality when we are passing to the model as a trained data. But once we create equal importance to both of these, okay, when we are passing, it's our job to create equal importance to both of these columns or any number of input columns you have. So you should create equality between all the columns and then pass to the model. Okay, once you pass them, now it's model's job to calculate and tell us which column is contributing more or less in prediction. If model is saying, that's fine. Okay, because it is doing some measurements and giving us a contribution. contribution ratings, like which one is more important than another one. But as an user, when you are sending, you should not be biased. Okay, that is the reason. But if you send it like in this way, this will be biased because both of the ranges are different. So to avoid that, we scale the data sets. Sorry, we scale the columns. So scaling is what? Bringing them into same range. Okay, bringing the data sets into same range. So is the scaling meaning clear, guys? Why we need to scale?
Yes, Santosh.
Okay, so now since we understood scaling, okay, so there are usually two types of scaling, guys. Okay, I'm not going into depth, but just since we understood what the fundamental idea of scaling is, to bring to the same range, okay, so that the model treats equally before it's getting trained. Okay, once it is trained, then its model will say which is more important, but initially it will treat them equally. So coming to scaling, usually you have two types of scaling, guys. Okay, one is standard. Oh, sorry. Okay, one is knowledge. Okay, so as you can see from where you are bringing, importing the scalar from scalar. So everything what we require, we get it from scalar only. Okay, so from scalar, but from where you are getting? From scalar pre-processing. Okay, but earlier if you observe, this is from scalar model selection. From model selection, we are getting train test split. Okay, but and from pre-processing, you are getting standard scalar. Okay, from okay, sorry, this is not normalization, this is min max scalar. Sorry, my bad. Okay, this is min max scalar. Okay, this is standard scalar. Okay, fine. So you're importing, see, I'm doing this, right? So when I, okay, this gets imported. But from the pre-processing, if you just press tab, so you'll also find all types of what all you can do. See, you are having min-max scalar also. Okay, similarly, you have standard scalar. Now, what is the difference between these two is min-max scalar will convert the given range between 0 to 1. Whatever be the range, if you use min-max scalar, the whole values will be converted between 0 to 1. Okay. Standard scalar will just standardize the given column. And what is standardization? You remember, right? It will convert into standard normal distribution. Okay, where the mean will be equal to 0 and standard deviation will be equal to 1. Okay, whatever be the column CGPA, now you're having CGPA, right? So the whole column, it will standardize. That means it will convert each row, each column into corresponding column, such that the new column will be a standard normal distribution. That means the mean will be equal to 0 and standard deviation equal to 1. Similarly for IQ, for every column, for every row in this column, okay, it will create a new column such that this new IQ column will be in the standard normal distribution. Okay, but when you use, for example, if you use min-max scalar, let's say you're using a CGPA column, it will create a, for every row, it will create a new corresponding value. Okay, for every value over here, it will correspond such that new CGPA values will be between 0 to 1. Every value will be between 0 to 1. Getting, guys? So over here, if you see what is the actual value of xtrain or in xtrain, yeah, in xtrain, let me print it again over here so that you will understand better. Oh, but okay. See, my extent is this 65. Just focus on CGPA. It is 65, 6.5, 4.9. Okay. Now what I'm doing, I'm importing min-max scalar. See, I'm importing min-max scalar. Okay. Forget about this. Okay. We are using only one. We should use only one scalar. Okay. Standard scalar. And from this standard scalar, I'm creating an object. This is the way how you can create an object. Agree? Now you are creating an object. Scalar is my, now my scalar is my standard scalar. Okay. To this scalar, I am doing what? Scalar dot, I'm doing fit and transform. Okay. We need to do fit and transform. That means fit and also transform the given values. Okay. So scalar dot fit transform. And to this, I'm passing my x train. Okay. When you pass x train, I'm using the same variable x train. Okay. You can use another variable also, but I'm using the same variable. Okay. So, but just to show you guys, just to show you what I will do is I'll say x train underscore, I will say standard. Okay. And now when I run this, okay, it has converted the column. Okay. Now if I print this, okay, now if you see, only this first column is for CGPA and second column is for the IQ. Okay. So, and as you can see, some are -1, some are +1, because you know that what in standard normal distribution, the values will range between -3 to 3. Okay. The maximum value will be 3 and minimum value will be -3, and the mean will be equal to 0 and standard deviation equal to 1. Okay. If you calculate these values for this column, you will get similar to these values. Same thing for this is for IQ, this is for CGPA. Getting guys, how you can use standard scalar? Simple. Import, create an object, pass the values using fit and transform. That's it.
Yeah,
Clear?
Santosh.
Okay. Sirisha, any doubts?
Transform, sir. Fit and transform.
Huh.
What is fit and transform, sir? I didn't understand.
Fit and transform means it is a code. Using the scalar object, when you should use fit and transform, that means we are saying fit the scalar on this x train and also transform the values into corresponding values. Okay. When you say scalar dot fit and transform, so it is the whatever it is a code you should use so that it will fit the scalar object, whatever the scalar object you are using, standard scalar object, and transform the values. Okay. So when you say fit and transform, it will do this. It is a function. Okay. If you say what is pandas ilock, what is that? What is pandas lock? What is that? What is df dot head? These are functions, right? Similarly, fit and transform is also a function. To this function, you're passing these values x train so that you are getting the standardized values. Okay. Fine. So now we should use only one scalar. Okay. But since I discussed about two scalars like min-max scalar, okay, I'll just show you as an example. Okay. We are not using that, but see, you can use any scalar. Okay. But I'll just show you how min-max scalar looks like. Okay. Same procedure. Import the min-max scalar from SKLM pre-processing, create an object, okay, and fit to the M scalar, fit and transform your x state, and I'll call it as min-max. Okay. And once I see this min-max, now you see guys. Earlier when I used standard scalar, okay, this is for CGPA, this is for IQ, right? So what I said, standard scalar, what it will do, it will standardize the given column. Okay, that means it will convert it into standard normal distribution, mean 0, standard deviation equal to 1. So that's why you when mean should be equal to 0, there should be some values less than 0 and some values greater than 0. That means you will have some negative and you will have positive values. That's why you can see all these negative values and positive values. Okay, in standardization. But when you use min-max scalar, that means, guys, are you understanding this row? See, what is this? If you see over here, you're having 60 in CGPA. First value is 66.5, 4.9, 5.4, right? So this 6.5 corresponding value is now this. Okay, and remaining 4.5 corresponding value is this. Okay, so like that, for each and every value, 90 values, the corresponding values are this, as per the standard scalar. Okay, guys. I hope you are getting that. Okay.
Yeah.
Oh, now forget about standard scalar. Now over here, when I use min-max scalar on the same extreme, okay, from the same extreme, when you do that, what did I say? Min-max scalar, okay, min-max scalar will convert the whole column between 0 and 1. Okay, whole column it will divide, convert it into 0 and 1, the corresponding values. So here, if you see, when I do min-max scalar, this is for CGPA, same. Okay, this is for CGPA and this is for IQ. Okay, now if you observe any column, see first, if you observe this column, every value is just between 0 and 1. Nothing is greater than 1 or less than 0. Okay, you might have maximum 1, see here, or you are having minimum 0, but every other value is between these two. You cannot say any negative values or any greater than 1 values. Clear?
Yes, this is only between 0 to 1.
Correct. So now here also same. For example, if you see IQ 130, its corresponding value is now 0.47. Okay, and 196 0.81. Okay, so how it is converting, we will see when we are discussing scaling. But if you are just having doubt, see whatever the difference in the scale in IQ, now in raw data, IQ is in some other scale, I mean some other range. Okay, it will try to follow the same range over here, because if you see IQ 130 is now equal to 0.47. Okay, and 196 is now become 0.81. So obviously now the second value is always greater than the first value. Getting? And if you see the third value is 114, now it becomes 0.39. Okay, so whatever the difference it is having in this range, okay, so internally it will from 0 to 1 range, it will also try to create that difference. It will try to maintain that difference. Okay, so how it is doing, I will try to show an example. Okay, later when we discuss this. Okay, but as of now, just it is okay to understand. Okay, the values, each of these values is getting converted into corresponding a value between 0 to 1. Okay, so every value will have a corresponding value to 0 to 1. Okay, fine. So that's about the min-max scalar, guys, and the standard scalar. Okay, there might be other scalars also, but mostly we will use one of these two scalar. Okay, fine. So let me comment this because I have just used to show you as an example. Okay, but in this for our data set, we will use standard scalar. Okay, so let me use the same xtrain. Okay, so now I'm running this xtrain. Now this is my xtrain corresponding values. Okay, fine. So now after that, for X test also you should scale. This is very, very important, because what we're doing, see, if you go back, now we got from train test split, we got this X train, Y train, X test, Y test we got. Okay, now we want, what happened next, we planned, okay, we planned to pass this data X train and Y train to the model, but we understood Y train is okay, but X train is having some issue, that scaling issue. For that reason, we have employed this technique called as standard scalar, and we have scaled the X train. Okay, now this X train is not the raw data. Now X train is not this data. Now X train is what? It is this data. Okay, it is this data. Agree? Now we are passing new X train to the model. Okay, along with the Y. Agree? Now what? Now the actual important point is finally what you are passing to the model. Okay, what all you are doing, that is your vision will. Okay, but finally what you are passing, in our case, in some cases you might pass direct values if everything is fine. In some cases you might need to scale. Now we are doing the scaling and we are sending the data. Okay, That is important. Finally, what you are passing to the model, that is important. So finally, what I'm passing? I'm passing the scaled data set. Okay. I'm passing the scaled data set to my model. Agree? Now that is important because whatever you are doing on the training data, you should do same thing to the test data also. Why? The question is why? Because with common sense, if we think as a model, whatever it is trained upon, it can work on the same data, right? That means, for example, you are training it on a range of hundreds, okay? And but while testing, you are testing it on decimals or negative values, it will not work, right? Because the training data is getting completely mismatched with the test data, okay? So that's the reason, if you don't scale, if you pass directly these values for training, while testing also you can pass without scaling. But if you are scaling and sending while training, if you are scaling this data and sending, while testing also you should scale this, okay? Because whatever X-train is going through, X-test should also go through, because when you are passing this scale data to the model and the model is getting, okay, trained on this, then it will expect the similar kind of data, not same data, similar. Try to understand the difference. It will expect, you can give any values, but the scale should be same. Otherwise, you will get some wrong values. How we know that the data is in not proper order? What do you mean by proper order, Sirisha?
Before we are going to scaling, we have to know, no, sir. The data should be in a correct form.
No, but what do you mean by form? I'm not getting. What do you mean by form?
Yeah, sir. We are ranging according to the scaling, no, sir. We are doing the ranging according to the scaling.
Correct.
So how we know the data should convert into the scaling?
If by seeing the range, right? So by just looking at it, if you see here, what is the range of this CGPA? These are all less than 10 values. Agree? CGPA is less than 10 values. Or what is this IQ? IQ, most of the values are greater than 100. Do you think these are falling in the same range? No, the range of this CGPA is different. Range of IQ is different. So scaling is obviously necessary. You can see, right?
Yes,
If
sir,
they're
got it.
if they're somewhat similar, for example, if CGPA is ranging from 1 to 10 and IQ is ranging some, let's say 5 to 15, it is okay. The scaling, it's not much difference. Okay. But if you're having a particular column between just decimals like 0.1 to like 0.5, and some other column is having some 50 to 60, between the range is 50 to 60, here the range is 0.1 to 0.5. So obviously there is much difference. Okay, by looking at the columns, you can decide whether you want to scale or not.
Thank you, sir.
Okay, is that clear?
Yes, sir, clear.
Fine. So going back, yeah. So I was saying, if you are scaling the data set and sending to the model will expect the same kind of data from the test also. Okay. So while from X-test also, this X-test also, you should pass through the same scaling what you have done and then pass for testing. Is this point clear, guys? This is very important, because what happens, see, you can ask, what if I don't do? Even if you don't do anything also, the model will give you definitely some results, but it will give you some unwanted results or Zenk results accuracy. Okay. Usually what people do, they will divide, they will take this data, they'll use train test split, they'll get these 4 values. Okay. And they'll just focus on this X-train. Okay. So they will try min-max scaler, standard scaler, etc. Okay. Somewhere they will fix on some scaler and they will pass to the model. Okay. And then they'll check the training accuracy. Okay. We understood, right? Training accuracy. They will get some decent accuracy. Then they'll think, okay, model is working fine. Till that point, they're good. But whatever the X-test they have, they will directly pass X-test. They will forget about to apply the same scaling steps what they have used for the X-train. Okay, they will forget, they'll directly use X-test. But what is the problem? Now X-train is in standard scalar format, that means this format, but X-test is in the still original format, this format, if you don't scale. Okay, so what's happening? You are training the model on completely different range of values, Okay, but we are testing on completely different range of values. Obviously, the model will not perform well, right? So it's always important to remember what type of steps you are using on this X-train. Okay, I'm not saying only scaling. You might do scaling, or you might what do you say? You might use many other techniques. Okay, I cannot remember exactly like what all different sort of things you can do, but as and when we discuss, I will let you know. Okay, but the important point is whatever technique you are using on the X-train, like and what all transformations you are using. Okay, yeah. For example, apart from training, if you are transforming this column, okay, there are a few transformations. I'll let you know. Okay, those transformations you should apply to the X-test also. Okay, finally, X-train and X-test should go parallelly. Okay, getting, is this point clear to everyone?
Yes, Santosh.
Okay, fine. So now, since we understood that, okay, so we got X-train, and similarly, what we are doing, yeah, so we are doing same thing to the X-test also. But there is one thing you need to note here. Okay, so when we are using the scalar object for the first time, okay, you need to say scalar dot fit transform. Okay, for the first time when you're using on X-train, okay, you have created the object, you have imported, you have created, and when you're using scalar dot, you should say fit transform and pass the X-train. Okay, it has done. But once it has already, you are done fit and transform, from next time when you are using it on the X-test, you don't need to say fit and transform, just you need to say transform. Okay, fine. So because it is already fit on the X-train, so it knows the range and etc. Okay, now it will just, if you can, you just say scalar dot transform. Okay, so let me say scalar dot transform. Okay, and these are the corresponding values. Okay, so now X-train and X-test both are in the same transformation. Okay, that means X-train we have used a scalar, and X-test also we are using a scalar. Okay, this Y-train, Y-test are just the output values. So most of the time we will not work much on the output columns. It will be just, if it is in the classification, it will be just some categories like 0, 1, 2, 3, etc. Okay, so there is not much thing to do, but that is the most important column. The reason why we are doing everything is because of this output column to get some predictions. But we will work mostly on the input columns like X-train, X-test. But mostly everything will be happening on this X-train only, guys. Okay, whatever you are doing, most of the time you will spend on this X-train, because this is the input column. Okay, whether you are working on the missing values, whether you are working on some column transformations or scalings or anything, what you do, X-train. Same thing, once you do step by step, same thing you will use it on the X-test in a single shot. Okay, fine. So now going back, now you got X-train, X-test. Okay, now data is also ready. Fine, data is also ready, scaling is also done. Next you need to pass it to the model over here. Okay, now what is the model? Okay, as of now we are using a simple logistic regression. Okay, so as I said, I'm not going into models now, but I hope I have already discussed. Did I just give you a brief about different algorithms? Yeah, so over here if you see, the other day we were discussing in supervised, you have regression classification. Okay, but this problem, what is this classification or regression is?
Classification.
Okay, this is classification because you're having categories 0 and 1. Okay, so over here you're having classification. So in this classification, these are all the algorithms. Okay, so logistic regression, K-NN, IVS. Okay, this logistic regression is a simple and basic classification algorithm. Okay, so the name is logistic regression, but don't get confused. This is actually classification. Okay, so we are using this in our case. Okay, but why did we choose this? That all will be a different scenario. Okay, but just to show you end to end, we have used this logistic regression. Okay, and how you are going to do that? Simple. From sklearn.linear model, you are importing logistic regression. Okay, and create an object. Everything is similar, guys. So whether you're doing train test split or mainly scalar, standard scalar, everything is we'll import, we'll create an object, and we'll pass the data. That's it. Clear? Here also, what did we do? See, simple. We are importing the standard scalar. We are creating an object and we are passing. And this for scalar, you will do fit transform and you will pass the data. Here also, what we are doing? Very simple. You are importing the model. How you are importing the model? This you should remember is for Mescalon linear model, import logistic regression. Okay. So this single step will import the complete logistic regression algorithm back math. I would say related logics and maths, everything that is required for logistic regression. We'll study what is logistic regression, how it will work. Okay, but whatever the whole concepts of logistic regression can be downloaded with just one input. Okay, so when you say SQL import, so this logistic regression is having the complete logic of logistic regression algorithm and max and whatever the calculations you need to do. Okay, so simply import in one line and then create a object from this. Okay, logistic, when you do this, okay, when you do this, you're creating an object, okay, with this parenthesis. So my CLF is my logistic regression object. Okay, to this you need to just fit our data. Okay, simple. CLF.fit. You do dot fit and pass your data. Now what data? Training data. That is important. Okay, what all we have done till now, that is my training data. What is my training data? X train and Y train. Okay, now what is this X train? This is the scaled X train. Okay, don't remember that. If you're getting confused, you can use the column. You can create it as X train underscore scale also, but we have used X train and Y train. Okay, now CLF.fit will do the training. So simple. You see, the training can be done in one single line with just few words. This is our model CLF. I'm just saying dot fit. That's it. Nothing more is required. Dot fit, pass the input and output. Done. Training is completed. See how simple the code. Okay. So now when I do, okay, now let me run it again. So I'm doing logistic regression imported. Now CLF is, I'm creating an object. I'm just saying CLF dot fit. Done. Okay. Okay. Now training is done. Okay, so ypred equal to CLF dot predict X test. Okay, so now see, I got X train, Y train. I passed to the model. Okay, done. So after that, I'm passing this X test. Okay, so I'm passing this X test. Okay, so understand we need to pass this X train, check the accuracy. Okay, that is a detailed step-by-step process. Okay, like for proper model evaluation. Okay, we can do that, but as an example, just for the toy data set. Okay, so just assume that you are getting good training accuracy, so you are passing. Let me pass this X test. Okay, now I'm passing. First time pass these two, I got the model. Now I'm passing this X test. Okay, passing what? Passing this X test. Okay, and I'm not passing Y test, I'm just passing X test. So the model should give me ypred. Okay, now when I compare this ypred with this Y test, I'll get the testing accuracy. Okay, I hope you are following this. So same thing I'm doing it over here. So if you see here, I'm passing to this model. What is my model now? CLF is my model. So CLF.predict, I'm passing this X test. Okay, what is this X test I'm passing? Now, whatever you are giving this, the output of this is ypred. Okay, when you do CLF.predict, the model will give you predictions, and those predictions I'm calling it as ypred. Okay, that means this I got, ypred I got. So I already have Y test. So when I compare ypred and Y test, okay, so this is my Y test, which is already present. Okay, which is already present. Getting? So when I need to compare between what? Ypred and Y test. How can I compare? Same again from sklearn.metrics. You have something called as accuracy score to find out the accuracy. Okay, from sklearn.metrics, import accuracy score. Right? To this accuracy score, I'm passing. What I need to pass? These two. This is my actual value, Y test, and this is my predicted value. Getting? Y test is my actual value for this X test, and ypred is my predicted values for the same X test. Clear? So I'm passing Y test. This is Y test, and this is ypred. Okay, but if you want to see the ypred, let me also show you ypred how it looks like. It is also just same values. See, same 0, 0, and some same values, but predicted values from the model. When you're saying SL.predict. Okay, see for fit, you use fit word guys. Very simple. To train the model, you use fit. To predict. Very simple. Okay, So fitting is done, predictions we got, y pred, these are the actual values. You're importing accuracy score. To this you are passing. Y test you are passing. Getting? So y test and this is actual values and y pred are the predicted values. Okay. So when you do that, you got 90% accuracy. Is it clear, guys? Okay. Why? Because it is comparing this. Okay, these are the predicted values, right? So for example, if I write it over here, okay, for your understanding, if I just write y pred, okay, if I write y pred and it 0 0 1 1, right? 0 0 1, sorry, 1 1 and 0 1 0 0 1 0 and last three are 1 1 1. Okay, 1 1 1. These are predicted values. So if you see, this is 1 1. Okay, same 1 0 0 0 is same. Okay, 1 1 is same, 0 0 is same, 1 1 is same. Only here, only one difference I'm seeing, 0 and here it is 0, here it is 1. Okay, above 0 0. Everywhere the actual value is equal to predicted value. Only over here it is different. Agree? So overall 10 values are there. In that only one value is failing. Okay, that means remaining 9 values it is working fine. That means what is accuracy? 90%. That's what it is saying, 0.9. Are you getting, guys? This is clear.
Yeah, Santosh, it's clear. So in general, yeah, till now it's clear. So normal in general, is there any limit on the like train data, test data, like are in lakhs or millions, Santosh?
You're asking the data set
Yeah, data set size. It
size.
depends
No,
for training.
no, there is no limit. Okay,
There's no limit, right?
no, there is no limit. But you usually in the for practices, okay, or
Yeah,
for mini projects, it will be few MBs of data, but in the
Okay.
practical purpose, it will be few GBs of the data.
Okay.
Okay, but you will have some at least few lakhs of data, lakhs of rows also you will work.
Okay. As well as this X train, Y train, X test, this is standard ones like Pandas as MP, like that. I mean, NumPy as NP. Is it standard or we'll use like as a input train, input test in coming to the
No.
practical?
Okay. These names you are saying, right?
Correct.
Extreme wide range. Okay, that's a
Correct.
good question. That's a very good question. But see, these are standard. Okay, but as I said, nothing is fixed in Python. So when I see, for example, when I'm doing this import in numpy.np, so numpy is the actual name, but I'm importing it as np. Okay, but
Correct.
there is no rule that we should use np. You can use Karthik also. That will also work.
Yes,
Okay,
yes.
but mostly these are the rules. Okay, so that if some other sees your code, they will easily understand. Okay, but if you go by rules, there is no rule that it should be always np. You can use anything. Okay, but it is recommended to use this so that you not confuse other person. Over here
So
also,
yeah,
you can use any name.
correct.
Okay, because these are the variables you are creating. Agree? This is the
Correct,
variable,
correct.
this is a function, and this is the output of the function we are creating. Okay, so as you can say, a function give you multiple outputs. In functions, I think in Python we have discussed a function, it can give multiple outputs. So directly you can collect it into different variables. Okay, so this output, this function is giving will give you 4 outputs. So you are collecting in 4 variables. So you can use any name. Okay, but most of the 100% it is recommended not to use any other names. Okay, because
Okay.
you get habituated to this. Because if you see most of if you see some other codes on GitHub also, everybody will use this. Okay, but
Okay.
so it's better to get habituated and use this again and again. If you start using something other, it is okay if you have that processing, that's fine. But why to use some other names, right?
Yeah,
So
that's what I
everybody
want to know.
using this.
It's a standard,
Yeah.
I mean, it's a recommended one.
Yes, it's standard recommended one. Okay, but no rule. If you go to technically, if you ask, no
Yes,
rule, but it is highly
yes.
recommended. Okay,
Okay,
fine.
okay.
So this is how you are getting. Yesterday I've shown you theoretically, okay, how you will what you should pass and how you will get the accuracy. Today, practically, you can see that you're passing y test, y pred 0.9. Clear, everybody?
Yeah, Santosh, clear.
Okay. So now, just as an example, let's try to check the training accuracy also. Okay, you're having this training accuracy, right? So we'll check that also. How you can do? Same thing for training accuracy. What you need to do, you need to pass the only X train. Then model will give you Y train pred. Compare Y train and Y train pred. Clear? So let's do that. Okay. So for example, over here, what I will do is I'll say Y TR pred. Okay. But first of all, I'm getting okay. If you're getting confused, we'll do this. For this model, I want to predict passing only X test. Sorry, X train. Okay. Getting? So for the training accuracy, you should pass only X train. Fine. So I'm passing X train. This model will give you output. What is this called? I will call it as Y train pred. Okay. This Y train pred. Okay. So I'm getting Y train pred. Fine. I got Y train pred. So after that, let me see the Y train pred. Okay. Some 90 values. That's fine. Then if you want to find out the accuracy score, same accuracy score, I can also use over here. Okay. But over here, what I should pass? I should pass my Y train and Y train pred. Okay. The actual Y train is this Y train. Okay. And its corresponding predictor value is Y train pred. Agree? Now when I do this, I'm getting 0.91 accuracy. Okay. On the training data set, it is giving me 0.91 accuracy. On the test data set, it is giving me 0.9 accuracy. Okay. How to find out the training and test accuracies? I think now you're clear and it's very simple. Okay. Just pass whatever the accuracy you want. If I want training accuracy, just pass X train. You will get corresponding Y train values. And you already have actual Y train values. Just pass to accuracy score. You will get the value. Okay. So if it is test, pass the X test, you will get the Y pred. But you already have the actual Y test, corresponding actual values, predicted values, pass to accuracy score. Got it. 0.9. Clear?
Yeah, Santosh, clear.
Okay, cool. So I think now we are theoretically and also practically clear how to calculate till training accuracy and test accuracy. Okay, great. So that's fine. So that is still okay. This is an actual conclusion which we can have. So if you are having accuracy, let's say you got decent training accuracy and then test accuracy you got 90%. 90% also very good accuracy, test accuracy. Okay, so you can say this model is good. Okay, your CLF model is good. Okay, so post that we will see few more things, interesting things. Okay, now this is our data set, right? If you go back, this is our data set. Okay, this is our data set, CGPA IQ. So if you see how it has divided, okay, once how the model is dividing these two data sets, this data set is this way. Okay, so just for showing you, okay, so that you'll have good understanding. So for this you need to from ML extend dot plotting import plot decision trees. Okay, there is one function. Okay, to these values, okay, to these values, if you're passing X train and Y train values, okay, X train and Y train values you are passing, okay, but based upon CLF you want to segregate. Okay, what is this CLF? CLF is my model. Okay, so if I just show you this plot decision regions, so see, every time you don't understand something, just Google it, you will find out easily. So when I say from ML extend, I'm importing this plot decision. Okay, if you just go over here from you will have ML extend library. Over here you have plot decision regions. Okay, so over here you are having all this. See, it is saying the X value, Y value, and CLF is a classifier object. That means it must have predict method. Okay, so if you use for in this CLF parameter, you should pass the classifier object. Okay, so what is our classifier over here? My logistic regression. The CLF is my classifier object. Okay, it's the same CLF I'm using. Okay, the name is same. Okay, fine. So over here, I'm saying divide the X train and Y train values. Show me with respect to this classifier object. Okay, see this CLF is from this CLF in the actual syntax. Okay, we have created our model with also the same name CLF. Okay, don't get confused. Okay, fine. So I'm saying plot these two values X train, Y train, but show me with respect to my model, my classifier CLF. Okay, so now when you do this, see, it has divided it into two values. Okay, my classifier, what did it do? see what did you do white train? Extend values. So my classifier is saying all these values are zeros and all these values are ones. Okay, so it has divided my logistic regression. What does this mean? This is meaning that my extended and wide range, when you are using before the model classification you have done, it is looking like this. But once you have used the classification model, the point is to classify them into two different groups. Okay, now it is dividing based what calculation mathematics it has done. Let's ignore as of now, but it is saying this till this point, it is saying all zeros is coming over here and all ones are coming over here. All these points. Okay, so as we have seen, so if you go up, yeah, so all these points became zeros and this is became ones. Okay, so that is how it is. Clearly the model is segregating. The model is what? Line. Logistic regression, the model is also line. Okay, so I hope you remember we discussed briefly, not in detail, but briefly, linear regression. But what is the model in linear regression? Ultimately line, because we are trying to find the best fit line. Do you remember this concept, guys?
Yes, Santosh.
Okay, similarly in logistic regression also, the model is line. Okay, that means we are looking for a line which will divide the given data set into two groups. Okay, so over here it is able to divide it into two groups, and it is saying this left side are segregated as 0 class and right side as into class 1. Okay, so this just for your visualization understanding. Okay, fine. So once we have done this, what we are going to do over here is see, okay, we got the model. What is our model? CLF. Okay, so now we have started this notebook. We have written everything. We got the model. We trained the model. We got the accuracy. Fine. Now CLF is a model. Now, if I shut down this notebook, this kernel, whatever this called, this kernel will die. You lose everything. Agree? What all you have done from past 1 hour or 2 hours, you lose them. Okay. To avoid that, because you already got the model, what you can do is you can just download the model, and it is called Pickle. Did we discuss Pickle library? I think we have already discussed Pickle in Python, right? I shown you a few examples. Did we? Can someone confirm?
On a brief note, we discussed Santosh, I guess.
Yeah, I think I have shown you how to pickle. Yeah, we have done JSON pickling. I think we have done. Okay, fine. Anyways, Pickle is a small library in Python, okay, which will help us to download and load objects, okay, whether it is a model or whether it is standard scalar object or few other objects which we'll see. Okay, so over here my CLF is my model. Okay, and I just import Pickle, and I'm saying pickle.dump. Dump in the sense just download. Okay, what I want to download, I want to dump my model, where I'm just creating some Pickle file. Okay, just open any name. I'm giving model.pickle in what? In binary format. Okay, so whatever the model is there, CLF. Now what is CLF, guys? My model. Okay, when I run CLF, what you will get? This is just a logistic regression model. Inside this, what you will have? It will be just some weights and values. You cannot see that, but ultimately what is this logistic regression? It's just an algorithm. Algorithm in the sense what? It's just max. Inside that, it understood the relationship between this both input and output from the X-train and Y-train which you have passed. It has understood some correlation between those, and then it has stored them in some max form, some numbers form. Okay, some weights internally. I will show you later, but it will be in some weights. Okay, model is nothing but some weights. Okay, so those values it will store in a binary format. Okay, when you see WB, okay, we are reading and writing formats regarding in Python file section. We have studied this. Okay, so we are just saying pickle.dump. That means dump my model CLF, okay, into this pickle file called as a model.pickle file. You are creating. When you say open, if it is not present, it will create. You are writing WB. That means in the binary writing, you're writing W for writing, B for binary. Okay, you're writing this. Fine. So when I run this, let me just import Pickle and let me run this. Okay. So if I go over here, Let me search for what is this model dot, right? Let me search for PKL. Yeah, model dot PKL just seconds ago, few seconds ago, it got saved model dot PKL. Okay, now we got this model dot PKL. Okay, we got this model dot PKL and it is got saved. Now we are on safe side because even if I lose this kernel, okay, I don't need to train the model again because the ultimate point of training doing all this is to get the model, CLF model, to do the predictions. That I got and I also dumped it. Now it is available locally. Okay, now I have this model over here. Okay, now even if I again open new notebook, even if I don't need to do all this again. What I will do, I'll just use this model. How I'm going to do that? See, for dumping you will use dump, but now I'm using pickle.load for loading it back. Okay, I'm saying load it back from same location, but now RB, that means read. Observe the difference. While dumping, that means you are downloading, or you can say saving, you'll use WB, writing, you're writing. But now when you want to load it back, when you say load, here RB, that means read in the binary format. Okay, now I'm using some other using this model name. You can use any model name. Okay, for example, I'll use logistic regression model. Okay, see, I got the logistic regression model. I not do any training, I just loaded it back. Okay, now you can use this logistic regression and you can say predict and you can say X test. You can use directly predictions. Okay, see, it is giving me predictions. Agree? You can also pass X train also. See, X train also it is giving you. Oh. Okay, see, this is from X-train, X-test, right? So we are divided. If you want to give some other completely different value, okay, so let's say your friend is asking you, he is saying to use his values, so you can just use any value over here. Okay, for example, what are my it looks like X-test and Y-test, these values are this, right? So let me use any value over here. Okay, if for a single value, if you want to predict, okay, this is at a whole you are using X-train, Y-train, X-test, X-train, and also you can use X-test. Okay, it will give you values. But if you want to, for a single row, if you want to predict, just use double parenthesis because it requires a 2D array. Okay, so and you can give any value. Okay, for example, I'm using 0.1 is my CGPA. Okay, in the standardized. Okay, if you want to do standardized, you can do it again. Okay, and let's say 0.9 is my what do you say, IQ. So the value is 1. He's saying, yeah, he got selected. Getting? So you remember, right? 0 and 1. What are these? 0 is not selected, not placed, and 1 is placed. Okay, so that's how you can do the one single row prediction also, and this is for the overall X-test prediction. Okay, so this is how you can pickle the model also. Okay, so that you will not lose the model. So and simply load and you can do the predictions. Fine. Is it clear, guys? Everybody on
Santosh.
track? Okay, so fine. So that's all I would say. So this is a overall end-to-end. Okay, with a small simple data set. Okay, so there will be a lot more things we can add over here, but at least I hope you got clear picture at a high level picture what all will be what all we can do to train a simple ML model. Okay, so importing and just checking the values, creating X and Y, and after that using this simple train test split, getting these 4 values, and then if you want to do scaling, you can do scaling, and then do the same thing for testing and get the model, import the model, pass the X-train, Y-train, you will get the fit, just fitting will fit the model, and pass the X-train, you will get the predictions and accuracy scores. Okay, this is for visualization and this is for pickling. Okay, now you can pass this model, the CLF what you got, right? The CLF model.pickle, you can copy and send it over WhatsApp to any of your friend, and then the same result you will also get. Okay, fine. So that's about the simple end-to-end toy dataset, guys. Okay, so that's all for today. We'll continue tomorrow on other topics. Okay, are we good?
Yes, sir.
Any doubts?
Send this
No,
note.
sir. Yeah.
Sir, send this notebook, sir.
Yes, yes, I will send this notebook, I will send this data set also.
Yes, sir. We will do
Okay.
that.
Yeah, yeah, that is best. So I will send this data set. Okay. So run each and every step in your system. Okay. It will be very interesting because it's the first time you're working on a small end-to-end part. Okay. So explore, try different ways. I train with standard scaler. No, you don't need to use the same thing. Go for min-max scaler. Already the code is over here. Try this. You'll get different extent. Use that. See the accuracy, whether which is perfect. Okay. Do pickling, do everything. Okay, every step you try to explore something. Okay. Fine, guys. That's all from my end. Thanks.
Thanks, Santosh.